so let's get started. So clearly I am Dr. Walrond. I hope everybody recognizes that. Otherwise, it will be your first time in class. What Dr. Walrond and I do every single semester, literally, including the summer, is that he teaches, is in charge of everything, and I get to do reproductive physiology at the end. Apparently, reproductive physiology doesn't fit with anything else, so we'll kick it at the end, and it'll be fun. Okay? So for a class that is supposedly 200 plus students, something exciting must be going on tonight. You have a test. I hope there are no reproductive physiology questions on the exam. There shouldn't be, anyway. So any kind of concerns, like tomorrow I'll definitely tell the increased anxiety, frustration, anger, any kind of emotion related to the exam. I am not responsible for anything that's going to be on the exam. Okay. Now we have two awesome TAs in the back that you can also yell at, but they didn't put the exam together either. So any concerns, Dr. Walrond, he's to blame. Okay, so just study, get it all done, plow through it. But now we end up with this last little section, reproductive physiology. And just based on my own experience being in this class for a couple of years now, what is the biggest problem for you guys right now? Chapter? The shit is hard, yeah. Well, it is hard if you start reading it without me giving a chance to go over it. It is hard. Actually, it really is not hard. Okay? What's hard is we use a lot of jargon and a lot of complicated words. And raise your hand if you really enjoyed Dr. Walrond's section on hormones. A couple of people. So you guys are going to really enjoy this. It's going to be relatively easy. All of the rest of you, you're screwed. Okay? It's going to be a freak load of, this is hormones. It's hormones doing stuff. And we need to know where the hormones come from and what they do, and I know it sucks, okay? The good thing is there's a lot of repetitive stuff into this, okay? So that is number one. So like you said, very elegantly, shit's hard. What else? What's another concern? How many of you have gotten kind of used to Dr. Walrond's teaching? Yeah, I hope, well, at least if you were in class, then when we started in January, whatever, and now we're in April, okay? His teaching style, right? What can you tell me about his teaching style?
He just draws pictures and we don't know what's going on.
So somebody's clearly kind of lost with all the pictures and the writing and stuff like that. Now the good thing is, I mean, every instructor that you have has a different teaching style. Dr. Walrond is really good at what he does. He knows, he's a walking encyclopedia, and he knows how to use the board. Now, if you really enjoy that, then the next 7 lectures are really going to stink, because I don't use the board barely ever, okay? So what I use a lot is, and I'm really grateful to the invention of PowerPoint slides, okay? How many of you have looked at the slides coming ahead? Were there lots of words on it? No. Most of those words, most of those slides barely have any words on it. They're actually just mostly pictures, okay? So I strongly encourage you, I mean, all my slides are posted. Okay, they're on Canvas. Everything that I like to talk about starting today up until next Friday is already on Canvas. Okay, so what I would do is print it out and just write notes along as we go. That's all you have to do. Because the questions that I'm going to ask on the final exam are basically what we talk about in class. The pictures that I show and the stuff that I keep harping about. And I'll indicate on each slide what's important and what's not. I'll even tell you this is important, this may be on an exam. Those usually, if you haven't fallen asleep yet, those should wake you up and at least start highlighting something, okay? So it's really, I know it's causing some maybe anxiety. You're used to his exam questions. Maybe you haven't. I mean, if it's been pretty much F's throughout, then clearly you haven't gotten used to it. But, you know, at this stage in class, okay, the reproductive physiology is not going to be the end of all, okay? Usually the impact on the final grade or your BMS 300 final grade is minimal. Now, I still strongly encourage you to, because of the slides, and sometimes I'll put something on the board. The easiest way to actually learn the material is in classroom right now, okay? Because as we're going through this stuff, and you starting to highlight stuff, and starting to write stuff, and listen to me talk, even though some of the stuff that comes out of my mouth may make no sense, okay? You start memorizing it, okay? It's easy to gonna, the other thing, does Dr. Walrond ask questions at all during his lectures? Well, we're gonna have a lot of fun because I'm gonna ask a ton of questions, okay? Because the only way for me to figure out how much you know, or if I absolutely, or even if I make sense, is to find out how you guys answer my questions, okay? The other thing I could do, even though it's noon, and people should be awake at this point, I know some dude droning on and stuff, yeah, we'll put you to sleep. So my goal is for you to not fall asleep, okay? So it's gonna be a lot more interactive. It's really gonna be much more like a dialogue. Now, if this was my first semester teaching, then probably 5 seconds of sheer quietness would get me very uncomfortable. I've been teaching for many years now. I can stand here for 5 minutes in absolute silence until somebody answers, okay? Now, the awesome thing is, what is the topic we're gonna talk about? About what?
About sex.
Sex? Yes and no. So I hopefully, at some point in middle school and high school, we did have some sex ed class. At least we got that sort of figured out. But yeah, you're right. We are going to talk about sex in context of determining sex. Okay. What's the other words are we going to talk about? Everybody's favorite topic at any dinner conversation. Testicles, ovaries, right? So I know how uncomfortable that may be, but you know, I get paid to be here regardless of whether you guys answer questions. You guys had to pay handsomely to get an education, and the education part will come from answering questions, okay? Now this is fun, right? So far so good. Okay, there's nothing to do with your exam tonight. Everybody's thinking about that. What's on the exam? Renal? Yeah, I know renal a little bit. Renal, something GI, digestion, lungs too. I don't know anything about lungs. GI and renal I can help, but I'm not going to, not right now. Okay. So if you have, I hope you have access to the ebook because the reproductive system part has been updated and it should provide a good background, okay? It has more figures. Some of the figures are the same as what I'm going to talk about today or next week, okay? And if you just have a hard time keeping up, there's plenty of information there as well to kind of find some of this stuff again, okay? So teaching reproductive physiology, you could start at any one point, okay? Because it's really kind of the cycle of life, okay? If I start with male reproductive physiology, then most of the audience may think that I'm sexist. Why the hell will you start with male? That's not fair. I could also start with female. What's the problem with female reproductive physiology? Those few males in the audience are not going to care where I start. What's easier, male or female reproductive physiology? What do you think? Male easier? What do you guys think? No idea because you haven't had it yet? Right? Male is super easy. Okay? Just think about it this way. Males are pretty simple. Okay? It's really not that complicated. That's exactly how male reproductive physiology is. Now, what about females? Female reproductive. Complicated? Why does it? What makes female reproductive physiology complicated? They have what? Nothing? Sure?
There's more structures that you need to have in order to carry a baby.
Absolutely. There's more stuff because there is a cycle, if anything. And for the guys that didn't know that, yes, there is a reproductive cycle in females. Okay. There's more structures involved, more hormones. And if anything, by the time we're finished talking about the egg is released, we're only halfway there, right? Because the overall goal of reproductive physiology is when we start talking about fertilization, an embryo developing, a pregnancy, and at some point parturition, which means childbirth. Okay? So inherently, female reproductive physiology is a little bit more complex and intricate. Okay? But the good news is, next week, Friday, at 1 o'clock, we're all good to go, and you guys are all experts on reproductive physiology. And then it's your job to go educate your friends and family members and siblings and whatever. Okay? Okay, so I like to start not so much with, obviously, male or female. I don't like to start with female just because it's the most complicated part. So why would I start with the most complicated part? I like to start with the genetics part. And I already see a little bit of panic here and there. Not hardcore genetics, okay? But more the context of, like what you said, sex determination, okay? So what is sex determination?
X and Y chromosomes.
Okay, talking about chromosomes. Okay, so let's assume it's probably not going to happen, but at dinner tonight with your friends or family or whoever, you're going to talk about your awesome experience in BMS 300 because that's what you guys do, and you talk about you talk about sex determination and X and XY chromosomes. If you're talking to your spouse or your friend or boyfriend or girlfriend or whatever, they're just going to look at you like, what the hell are you talking about? What XX, what XY? If you had to put it in normal terms, sex determination, you're talking to your parents, if that's a possibility. What is sex determination? Anatomical differences. Okay, so now we're getting a little bit more focused. We're talking about differences. Yeah, so sex determination is really that basic question of what determines the sex of an individual. So how come I look like a male, or I am a male, whereas you're a female? What is the underlying cause for that? That is sex determination. Is that an interesting question? Or a stupid question? Can you imagine a certain situation or population that this is a very important question? Nobody that you know has ever wondered about the sex of an offspring. Developing youth? In what context?
Just learning about, wondering about how they're growing and developing.
Yeah?
Amongst their peers.
Okay, yeah, amongst their peers, male, boys versus girls. The whole puberty thing. We're going to spend about 2 minutes talking about puberty. As fascinating as puberty is, it's something we've all went through, and some of us are still stuck in it. But that's more like psychology-related stuff. How many of you know a couple or have known a couple that is expecting a baby? Right, most of you? Some of you just will never ever in the next week and a half raise your hand, which is okay. Got a powerful laser pointer here. At some point I'm going to blind you with it if you don't participate. Okay, what is the first question that couple wants to know? And I guess sorry, I have to apologize. It doesn't even have to be a couple this day and age, right? You can be single and still have babies. So, what is the first question? What is the first thing they want to know? Yeah, is it a boy or a girl? In a delivery room, how many people have you heard of that are asking the doctor, does my kid have 5 heads? Okay, nobody asks that stuff. Or even have 1 head, that would be good. Okay, that's actually necessary. Or how many hearts, or does it have the right number of limbs? Nobody cares about that stuff. Okay, but we do care about, and actually want to know from the get-go, when we make that first trip to the doctor's office because we're thinking we're pregnant, is, wonder if it's going to be a boy or a girl. Okay, so clearly that is of interest to everybody, and at some point in your life, if you're planning on having kids, you're going to be asking that same question. You're not going to be asking, oh boy, I just wish it was a baby, period. I don't care. You don't care really, but you still want to know at least a boy or a girl, but hopefully nothing that is without a sex. Okay, does it ever happen? Are babies born that you cannot tell whether it's a boy or a girl? Is it very common, you think? It's about 1 in 4,000 babies that are born. So I don't know if that's a lot, but can you imagine the anxiety or the stress levels that are happening then in the delivery room, right? That's causing way much more stress than a whole bunch of other things, okay? The other way to think about it, can you think of any cultural preferences in certain areas where they only want a boy or a girl? China, right? India, certain countries, there's definitely a preference for having boys, okay? So clearly, sex determination is of interest, okay? And it is important, okay? So do we already know, do you guys know, how is sex determined? How come some of you look like female and some of you look like male? Sorry? Hormones, okay. Hormones. Anything else? Hormones are definitely involved. We'll talk about hormones that are involved. Anything else? Very specifically. Genes. You're getting closer. Very good. Where do genes come from?
Chromosomes.
There you go. Chromosomes. Chromosomes. Okay. So do chromosomes dictate me looking like a male and a lot of you looking like female? Yes or no? You see? I know sometimes it feels like pulling teeth. Trust me, it's going to get easier and easier. Except Monday morning. Monday is just a shitty day for everybody, so it doesn't matter really, okay? Trust me, you guys are at noon. I teach BMS 360. That's at 8 o'clock in the morning. You should see those happy faces at 8 o'clock in the morning, okay? Okay, so we know quite a bit already about what dictates sex. What is involved? We talked about hormones. We mentioned genes, chromosomes, okay? Do you think people knew this way back when? What do you think they thought dictated the sex of the offspring? Reproductive organs. Yeah, they probably figured that something is going on there. Do you think they had any idea that you could dictate that? Meaning that you get to decide as a parent, you know, they figured out too that you need a male and a female in order to have a baby, okay? But can you influence the sex of your baby? Can you do something that if you wanted a boy, that's what you do and you have a boy? Or the other way around, a girl. So let's assume that everybody here is interested in having a baby. Is there anything you can do that will determine the offspring? Eating certain foods, drinking lots of wine.
I learned about, I think it was the howler monkey that their mothers, whenever they get pregnant, they eat a certain meat and
Seems to cause a direction a little bit. So that's in certain monkeys. There's definitely some certain species that can do something, okay? Whether that's actually happening really for the monkeys or more anecdotal, that's still kind of a big question mark.
Are they working on like some kind of biological designing so they can decide like it's not?
Oh, okay. So I really like where this is going. So is there something like artificially we can do that will help us determine I'm going to get a boy versus a girl? And this kind of goes towards the last lecture next week, Friday, when we're going to talk about something called assisted reproductive technologies, okay? Which really is applied reproductive biology, okay? So we'll do all the basic reproductive biology first, and then we're going to spend time talking about assisted reproductive technology. Who knows what assisted reproductive technology is? Can you give me an example? IVF. Who knows what IVF means? Well, you do, because otherwise you wouldn't have mentioned. In vitro fertilization. Who's never heard of in vitro fertilization? That's okay. Everybody knows what that is? Do you think it happens very often? Is it very common, or is it kind of a rare, odd kind of a thing? It's expensive. We'll talk about it next Friday. Actually, the way it is right now, and we'll talk a lot more about that next week, is this couples that are relying on in vitro fertilization increases every single year. Okay, so many couples really rely on in vitro fertilization in order to have babies. So we'll talk about how that could potentially play a role or could be manipulated to make sure that, you know what, I need to do in vitro fertilization, but I only want a boy, and what you can do in order to kind of help with that. Okay, but under normal conditions, okay, what I want to go through now is show you 3 slides. And if anything, what I want you to get away from this is, one, how incredibly stupid people used to be, which we kind of already knew, okay? But also recognize that some of this stupidity is still not going away, okay? And so if anything, if you don't care about any of the reproductive physiology and you don't ever want to talk about it ever again, hopefully if at some point you hear something in the news or your friends or somebody is saying something stupid related to this, correct them, okay? The first thing that I want to show you is how a very long time ago, what people thought dictated the sex of the offspring. Okay, so basically how this was regulated. Now, it's very important for me to indicate that these are not my thoughts or my opinions. Okay, because if you kind of look at this, again, long time ago, just as mankind, most perfect of all animals, so within mankind, the man is more perfect than the woman. Wow, that's a pretty ballsy statement for me to just say right in front of this classroom where 80% of the audience is female. Okay? How many of the men think that this is true? There's at least 2 there that are quiet right now, which is awesome. Okay? So clearly that's not what people believe, but back then, honestly, that's how it was. Okay? And really where this is going at is temperature, heat. Okay? The idea being that if during intercourse or during embryo development, if there was enough heat and the temperature was high enough, that would allow the reproductive organs to develop perfectly, and that would mean male. Female reproductive organs were considered imperfect. Okay? And so if there was not enough heat, that would just turn into development of female reproductive organs, and you were female. Okay? So do we agree with this or not? Definitely from the 80% of the audience that's sitting here right now, I would expect a little bit more of a vocal response. Is this true or not? No, of course not. Okay? Now, if we take the stupidity out of this, what is this saying, kind of, if you take a step back? The temperature may dictate the sex of the offspring. Does that ever happen? Yes, exactly. What situation? Certain species, okay? Turtles, certain snakes, reptiles, okay? Temperature clearly play a very important role in dictating the sex of the offspring, even if they have chromosomes that should direct development of males or females. They can actually override it, okay? So that's clearly of importance if you kind of consider, and without going into any kind of political debate right now, which I'm so not a politician, the whole global warming thing, okay? So let's just assume or pretend, okay, that is happening, and I have no opinion, really, I don't. I've learned many years ago, I'm not going to talk about global warming or any kind of hot topic issues in front of a classroom when I have to talk about reproductive physiology, okay? So let's assume there's global warming, okay? That means increase in temperature. The amount of temperature difference, for example, in some of the eggs that turtles lay, it's only a couple degrees difference, and either that egg hatches a male or that egg hatches a female turtle. If we're talking about global warming, that means that these species that have that kind of a mechanism, what do you think is going to happen? Yeah, all of a sudden, only one sex is being produced. If you do that at a population level, what's going to happen with that species? Yes, it's going to be gone, okay? So for some species, this actually is critical, okay? And this is a big problem, okay? Now in humans, I can tell you this obviously is nonsense, and temperature has nothing to do with either having a boy or a girl baby, okay? Temperature does not play a role. So the next slide, the next couple of years, 100 years later in this timeline, I think people just got stupider, not any smarter. Must have occurred during the invention of alcohol. But some of it here, couples should have intercourse in dry weather and north wind. Do you really think that that's going to determine the sex of the offspring? Okay, I have no idea. Okay, you need to have enough people doing it all at exactly the right time when there's a north wind and all this stuff going on. Okay. Now the next two, I have to really kind of implore on you not to try this out as an experiment, okay? Because it's really not going to happen. Ideas being that a man should wear boots to bed and get drunk, I don't think it has anything to do with the sex of the offspring, let alone having sex, okay? tie a string around his right testicle and cut off the left testicle. Now we're entering a dangerous arena here, because by the time you're starting to cut off testicles, it's not so much about the sex of the offspring anymore. It's really about having offspring, period. Okay? Yes?
So they used to blame the woman's reproductive system for the gender of the baby.
Mm-hmm.
And why were they saying that you have to do all this stuff to the guy?
Yeah, I don't know. That's a good question. I don't even know what brought them to think about just starting to cut off testicles in the first place, unless it's a scientist, because you could do this as a human experiment, right? We all know we can do human experiments right now, but boy, we're talking about quite a long time ago, and trust me, they were human experiments, okay? So as a scientist, you could do this, right? You find 100 male volunteers, and volunteers really between quotation marks, because I'm not sure how much volunteering they're doing, and you split them in two groups of 50. One group you cut off the right testicle, the other one the left testicle, and then you follow it up and see what the sex of the offspring is. What's the thinking behind this, besides clearly a lot of anger? But, well, yeah, birth control, but if you did just think about it, what must the hypothesis be if that's the experiment you want to do?
The right testicle would have more male semen. And
Yeah. For example, exactly. Let's say the hypothesis is, sperm that comes from the right testicle carries the Y chromosome, so that only can lead to male offspring. Sperm coming from the left testicle has X-bearing sperm, that only gives rise to females. Now, again, this is not in the 1900s or the 1800s, it's further back. Is by itself, though, way back when, does that seem like a plausible hypothesis? I mean, it's not horrendously stupid, right? I mean, the idea of, okay, there's two testicles, why the hell not? Right? On top of that, if you look at the next one, a woman should lay on her right side. Okay, so it goes back to the woman that maybe there's something about where the embryo, once it develops and when it travels to the uterus. Next week, we're going to talk about implantation of that embryo. If it implants on the left side versus the right side, could that dictate the sex of the offspring? Now, that's an experiment you really could never do, and you don't want to do. But again, something about left versus right side. Now, I really hope that people recognize that clearly these are not very bright ideas. These are also not things that I would encourage you to do, okay? Because it's really not going to work, okay? So we've kind of, and you think, boy, how silly is this? We almost spent half an hour talking about the craziest crap I've ever heard, okay? The only reason there's lots of reasons I can bring this up. Part of it is because it's fun. This is an article that was published on BBC News in December of 2016. I'm talking a little over a year ago, okay? And even though this was in a city in India, okay? And again, there's a cultural preference here for having only boys and not girls. And so basically what the doctors there did is write an article to parents and couples with some tips that they could do so to ensure that they would only get boys and not girls, okay? Again, we're not talking about a couple of hundred years ago. This is a year and a half ago, okay? And some of these tips include is that to have only, potential mothers on the day of conception, don't skip breakfast. That is advice number one, okay? Advice number two, okay? To have sex only on certain days of the week. It didn't specify what days, but maybe on Monday and Wednesday, you'll get a boy. If you do it on Tuesday and Thursday, you get a girl. Who knows? Okay? And then finally, the male or men should avoid any acidic foods because that makes sperm weak and you want the sperm to be strong. Again, this is a year and a half ago. So if anything, what I'm hoping that within today's lecture and tomorrow when we wrap it up, that if you ever hear something or read something as stupid as this, that just let them know how stupid they are, okay? Because none of this stuff will impact whether you as a couple or single are going to have a boy or a girl, okay? In fact, kind of what we talked about, what dictates this is chromosomal sex. Okay, chromosomal sex determination. Okay, so what I want you to do, if you have this printed out, there's going to be a couple of words I want you to add here and there. Okay, chromosomal sex determination is the first thing that happens. When does this happen? When does chromosomal sex determination happen? Fertilization, right? The picture is right there. So during fertilization, that's when we have chromosomal sex determination. That's when we, at the level of chromosomes, determine the sex of the offspring. Okay? That has to happen first before we start doing the other two things. Okay? The next thing that has to happen is something called gonadal sex determination. And what I want you to do here is, in front of gonadal, I want you to write primary. Because primary and gonadal sex determination are considered the same thing. Okay? So what is primary or gonadal sex determination? What's going on? What are we talking about? Pretend again you're educating your relatives. Sorry, say it again? Tissue determination. Okay, be more specific because you're exactly right. What tissue? Exactly, testes or ovaries. So gonads, okay, feel free to use it as a Scrabble word, but it really means testes or ovary, okay? So primary or gonadal sex determination means that initially both boys and girls have something considered kind of like a tissue primordium, okay? It's very underdeveloped, but it has the ability to either develop into a testis or it has the ability to develop into an ovary, okay? So depending on the chromosomes then, we either develop testis or ovary. And only when we have developed a testis or an ovary, when that is completed, we can have the final thing, which is phenotypic sex determination, or put next to it, secondary. Okay? So secondary or phenotypic sex determination. Okay? So what is phenotypic or secondary sex determination then? Physical expression of sex. If I were to put that on the exam and I'd leave it as an essay question, I could probably get anywhere from exactly the right answer to very graphic images that I really don't need to see. But it does relate to that. Think about, so what is phenotype? Phenotype is? The expression. Yeah, so how genes are expressed, right? So the way we look, our phenotype. My phenotype, I like to think, is male. Right? I don't know. It's true. It could be different because we didn't assign any chromosomal sex to me. Okay? So phenotypic sex determination is really, like I said, determining what you look like. And what we're going to talk about, obviously, is male or female. Okay? So secondary sex determination is looking like a male or female externally. So we're going to talk about the external genitalia. How do they develop, male versus female? Okay, secondary sex characteristics, okay, facial hair growth, widening of the hips, adipose tissue development, okay, all secondary phenotypic sex determinants, okay. Now what is missing there? Because that's only half of it. Hormonal regulation, you're exactly right. So all this stuff depends on hormones, but I'm talking about, I guess, more anatomy-wise. So we talked about the external phenotype, and we've talked about the gonads. We're still missing something. How many of you have heard of something called a uterus? What? The uterus. Not? Oh, there you go. That's okay. Vas deferens, epididymis, fallopian tubes. I know at least the women, which is again 80% of the audience, have heard of fallopian tubes, oviduct, or uterus. At least they know they have a uterus, whether they were pregnant or not. And if that still doesn't make any sense, then next week when we talk about the female reproductive cycle, it definitely will make sense. Okay? So we still have, besides gonads, a testis or ovary. Those things only do, so testes and ovaries only do two things. Very simple. They produce hormones, which are important, and they make gametes. That's it. So the testis makes sperm, the ovary makes eggs. Now, those things are going to leave that organ. Sperm does not stay in the testis. It's going to go out. Okay? The egg does not stay in the ovary. It's going to leave the ovary. Okay? So all the internal, kind of to put it bluntly, plumbing, okay, that relates to the reproductive organs, internal reproductive tract. Okay, so you can write down internal reproductive tract, okay, that all relates to secondary or phenotypic sex determination. Okay? Now, what is the one thing that's not on this slide that's also very important and that, unfortunately, I don't really have any time talking about? Related to sex. Think identity. Gender identity. That's a whole nother thing layer on top of this where regardless of what's going on here, but really the perception of feeling as a female or a male, regardless of whether you actually look like a male or a female. Okay? That's a fascinating other topic that unfortunately we can't get into. Okay, I want to talk a little bit about chromosomes, okay, without making this too much of a genetic lecture. I really want you to recognize that as humans, not as mammals, but as humans, we have a certain number of chromosomes. How many? 46? Yes. 23 pairs. And more specifically, we have 22 pairs of autosomes that we all have. And then we have a pair of sex chromosomes. Okay? So if you're female, you're XX. If you're male, you're XY. Okay? So in this case, we're talking about an individual that is XY. There's a very long X chromosome and there's a small Y chromosome. Okay? So, but I want you to keep remembering, even though we focus so much on the sex chromosomes, that anytime we talk about an egg or sperm, that they have all these 22 autosomes as well. Okay? And anytime we talk about an embryo, or before we talk about meiosis and stuff like that, when we talk about pairs, that means that this chromosome 7, one came from mom and one came from dad, for all of them. Okay? So a little later on, unfortunately, we have to talk about meiosis. I know that's everybody's favorite topic, but we'll make it pretty easy. Okay? So I really hope that everybody recognizes this, okay, which is really the inheritance of sex chromosomes. This is the most complicated genetics that we'll probably end up talking about. Okay? Female, XX, eggs always have 22 autosomes and an X chromosome. Sperm, on the other hand, have 22 autosomes and an X, or 22 autosomes and a Y. And depending on what happens with fertilization, we end up developing XX embryos and females, or XY embryos and males. Okay? So the recognition that there are X and Y chromosomes happened a long time ago. Okay? Early 1900s, X chromosome was identified, and in 1959, the Y chromosome was identified. But you have to kind of remember at that point, people really had no idea like what's causing what. Okay? The possibilities really would be that if you have one X chromosome, okay, does that mean you're a male? Or one Y chromosome, does that make you a male? Or do you need to have two X chromosomes to be a female? I mean, tons of possibilities here. Okay? So it wasn't until once we recognized that there are X and Y chromosomes that really became reliant on patients going to hospitals that had either reproductive problems and then finding out how that matched with their sex chromosomes and maybe mutations and things like that. Okay? So I only want to focus on two examples. One, for example, are patients that are, so get rid of the one, XXY. So again, they have 44 autosomes, but now they have 3 sex chromosomes, 2 X and a Y. Has anyone heard of this syndrome at all? Don't remember what it's called?
Is it intersex?
No, we'll talk about that later on too, intersex and stuff like that, and we'll also start calling it something different a little bit. No, not Down syndrome. Klinefelter, exactly, Klinefelter syndrome. This is Klinefelter syndrome, okay? Klinefelter syndrome happens fairly frequent. I think it's about 1 in 500, okay? What do these individuals look like, you think? Would we classify them as male or female? Male? Definitely male, okay? And the reason for this is they have testes. Okay? The one thing we call them male, but I have to recognize that this actually, people with Klinefelter syndrome have kind of a broad spectrum of phenotype. They can look like completely normal males to severely under-masculinized males. Okay? So there's a little bit of heterogeneity in phenotype. However, they do form testes. These testes usually are very small. They produce very little androgen, and that's depending on how much androgen is produced during certain critical stages, how masculinized they actually look or not. Okay? Okay, that suggests that maybe I need one Y chromosome, okay, for testes, or, but what about an ovary? Okay? So there are also patients that are XO. The O just means it's missing a sex chromosome. So in this case, we have 44 autosomes and one sex chromosome. Okay. Anyone remember what that syndrome is called? Yep, exactly. Turner syndrome. Turner syndrome. Okay. So Turner syndrome are individuals that are born that usually end up growing up with fairly short stature, characteristic webbing in the neck, and they do develop as female, in that they have ovaries, and I'm putting ovaries in quotation marks because these are non-functioning ovaries. And in fact, what happens with these individuals is they develop something called, that you may or may not have heard about, premature ovarian failure. Okay? So premature ovarian failure is a condition where a woman, kind of think of it as runs out of her eggs prematurely. Okay? And so basically, they end up being streaked gonads with no eggs in them. Okay, so these individuals are sterile, are infertile. Okay, now as common as this is, 90% of the embryos that develop as XO are actually never born and actually lead to spontaneous abortion very early on, a lot of times when the woman doesn't even know she's pregnant. Okay, so this is a lot rarer than that. Okay, so at least this got people thinking about, you know what, one X chromosome, or clearly no Y chromosome, I'm not getting any testes. Two X chromosomes clearly does help with normal functioning ovaries. Okay. And then finally, people did some really fancy experiments, okay, using mice, because that's what we use a lot for experiments, to really determine, well, what is it on the Y chromosome that actually can cause this. Okay. So on the Y chromosome, remember how small that was? There's only a handful of genes too. There's about, I think it's about 29 genes total. 16 of those genes are housekeeping genes that have some kind of a counterpart on the X chromosome as well. 9 genes are important for spermatogenesis or making sperm. And then we have that one gene that is important for testis development. That's it. Okay. And basically what these scientists did, they had an hypothesis. They figured that there's a gene on the Y chromosome, and they called it SRY. Okay. And this SRY gene is the factor in mammals that causes a gonad to develop into a testis. Okay. And so SRY stands for sex-determining region on the Y chromosome. Okay. And it comes from the Y chromosome, so it's something inherently that only XY individuals have. Okay. And what they did was they had embryos here. They collected XX fertilized eggs from mice. And all they did was they took a needle and they injected, they cloned the SRY gene and put that gene right into the genome of that XX embryo. And then they let it develop. So basically now you have an XX mouse that is completely normal XXY, but has just one extra gene, SRY. Not the Y chromosome, just that gene. And basically what happens now is this is what a normal mouse looks like externally as a male. The anal genital distance is fairly large. In females, it would be a lot closer. And this is an XX mouse that has the SRY gene, and externally she looks like a normal male. And internally, this is what a testis looks like via histology. And this is that XX mouse. Okay, so these mice end up developing testes. Externally, they look like a male. They had testes inside. The only thing they did not have is they are unable to make sperm. So for spermatogenesis, like I said, you need some of these other genes that are on the Y chromosome. They only got the SRY gene. Okay. So this is probably the most complicated figure that we're going to talk about, and there's a couple of key things that I want you to either highlight or at least make a note of that you need to know for the exam, okay? So, and those are highlighted in color right here. And that is as much genetics as we're going to do, okay? I want you to recognize again that we start out, whether you're XX or XY, with something called a bipotential gonad. So basically that's that gonadal primordium that has the ability to either develop as a testis or an ovary. So if we're XY and these cells are all XY, what happens first is that the Y chromosome, the SRY gene, is turned on, and this SRY gene is a transcription factor. So as a protein, it binds DNA and promoter regions, turns stuff on. Okay? The gene that it turns on is called SOX9. And what I want you to write next to it is that SOX9 is not on a sex chromosome. In fact, it is on one of the autosomes. That means that everybody in this room, regardless of whether you're male or female, you have SOX9. Okay? But SOX9 is very important because it will help push turning this bipotential, undifferentiated thing into a testis. Okay? On the female side, we are XX. We don't have a Y chromosome, we don't have SRY, but what we do really need are RSPO1, Win4, and beta-catenin. Now, the odd thing with these three things is, again, I expect you to be able to recognize these, okay? And I'm not going to put on the exam which of the following is important for ovarian development: RSPO1, RPSO1, OPRS1. I'm not going to scramble the words. Just recognize what is necessary for making an ovary, okay? All of these genes, and I want you to write next to it, those are all on autosomes. None of this stuff is on an X chromosome, even though we talked about the fact that you need 2 X chromosomes to make an ovary. We just don't know what it is on those X chromosomes. All we know is that these 3 genes that are all signaling molecules, so these are not transcription factors, all these 3 combined are necessary to take the bipotential thing and make it into an ovary. Does that make sense? Now, I want you to recognize the problem you have if you have autosomes, things on autosomes that control making a testis or an ovary, that can cause problems. In my situation, when I was an embryo, I did not want RSPO1, Win4, and beta-catenin to be turned on. Okay? When you're a female, you do not want SOX9 to be turned on, even though you have it. So these molecules antagonize each other. They're all on autosomes. So SOX9 actually inhibits RSPO1, Win4, and beta-catenin from turning on. And vice versa, when you're an XX embryo, these signaling molecules all inhibit SOX9 from turning on. Okay? Does that kind of make sense, that these are antagonizing pathways? They have to inhibit each other. We don't want both these pathways turning on, because in that case, you end up having something that, as you kind of indicated, intersex or hermaphrodites, or having a gonad that has both. And trust me, nobody in this room wants that. Okay? Does that make sense? Enough talk about testes and ovaries. Have a great day. Good luck on the exam. See you guys tomorrow.